Kevin, is the board visible to you all? Yes? Okay, good. Okay, good. So you're going to solve this as a minimization. Keeping in mind, in minimization, CJ minus ZJ, okay, should be greater than or equal to 0. Okay, keep in mind. And what you will do, you will check for what? For artificial variables, EM, for these penalties, for EM, you will check for the EM. If in the case of minimization, the artificial variable here will be plus M, not minus M in Z. Okay, in Z we have a plus M, let's say M1. Okay, M1. Clear? So please at least make the initial variable so that I can see. Look like this first. Let me show you for this one. For this one, it's I'm going to show you to convert it. Okay, we are going to convert this one. It's going to be converted. That one. We are going to convert x1 plus x2 is equal to 5. Okay, and convert this one x1 3x1 plus minus 4x2. This one, please look like this one. Look this one. I'm going to show you this and then you convert it. Okay, we are going to have x1 plus x2 is equal to 5, and this is subject to constraint. Okay, here we have a minimize, mini z. In a mini z we have x1 plus x2. Okay, let it be like that, no problem. And here we have, here let me put 3, x1 plus 3x2. And here we have like x1 plus x2, okay, is lesser than or equal to 3x1 plus is lesser than 4. And here we have minus x1 plus x2 is lesser or equal to minus 7. And here we have 2x1 plus 6x2, okay, they're greater than 12. Anybody can convert this one fast? Please convert this fast. Please convert the whole problem. Please convert this the whole problem, okay? Convert it. Let me try to balance, okay? Let me try to balance. Look here. Let me put here minus 2, okay? Let me put here 6, all right? 6, okay? Let me put here 4, correct? Yeah, please convert this one, convert the given, solve this one using, the question is solve, okay, LPP by what? By which one? By using big M method. Okay, solve this one. Please convert it and show me this one. First convert it, convert this one, and formulate the table as well. Formulate the table. All right. By formulating the table, please keep in mind what you have to include there. Please, first I want to see if you can do this one. I just want to check your answers within a few minutes. Okay, please do it. Do the first convert it, and then for those who finish, for those who complete to convert it, not all of you, please convert it and show me how it is. And as you are doing that one, as you are still, doing this conversion, all right, as you're still doing this conversion, I'd like to introduce to you one more topic here, which is called transportation problem, all right? Please pause a while, I will give you the last 1 minute, okay? Pause a while, all right? Pause a while. I'm going to introduce you this transportation problem for a few minutes, or only less than 5 minutes, okay? So for this transportation problem, let me introduce. This is another chapter which I want you to get to understand how it is. I hope my board is visible. Is the board visible? Only 5 minutes. I only use 5 minutes to explain this transportation problem. Is the board visible to you all? You can see? No? Hold on. Yeah. As I explained, please keep in mind my exercise which I gave you. I lazy it, you will show me. Okay. How is it now? Now, is it visible? You can see the board.
Yes, sir.
Okay, fine. So there is a case which I have realized for using a simplex method. So in using a simplex method, the problem was it's somehow complicated to find the optimum solution. To find what? The optimum or optimal solution. To find the optimal solution. Okay, so transportation problem came in to find the optimum solution of minimization or minimum cost of transporting goods from a source to a destination. Look here. Here we have a store. Let's take an example. Here we have a store, big store. Here we have a very big store. We have a storehouse. Let's take an example. This is in the city, Bangalore. All right. This city, Bangalore, contains goods. There are some goods. Let's say there are shoes and belt, shoes and a belt. So we want to ship or we want to transport the things which we have in Bangalore. Let me take here is near Alapulam. It's near Alapulam. Okay. And I want to send this thing to another city which is called Shantinagar. Okay. I want to send to another city which is called Shantinagar. So this store which is at Alapulam is known as a supply. This is a supply or this is a source. So to transport to the shop or to the store which is at Shantinagar, this is a Shantinagar, I think is correct. To transport to Shantinagar, this place which is this Shantinagar shop is known as a destination, correct? Destination, all right? Or this is known as what? Is known as a demand. Clear? So we want to find the minimum cost of transporting these goods to the destination. Okay, from a source to destination, what is going to be the minimum cost? You get it? This is the aim of transportation. The aim of transportation is to find the minimum what? Cost of transportation from source to a destination. Okay, from a source to a destination. So for this minimum, what do? We want to find these two things. We want to find the total. We want to find the total cost of, this is a total cost of, let me say, the summation of I. Summation of I, this is like to say the total source cost. Okay, this is the total source cost or the total amount which we need for the source, and C, the summation of Bj, this is the total amount of reaching destination for destination. So when total amount of source is equal to the, means that this is supply. When amount of supply, total amount of supply, let's take an example from this place, from this place is, let's take an example, it's going to cost me like 500, okay? And the destination also is going to cost me 500 to reach. So if the 500 of the source and the 500 the destination are equal, then we mean to say that this transportation is known as a balance. Okay, we known as a balance. When the total supply is a different when the total supply AI is a different to the total destination, then we say this is unbalanced transportation. Okay, this will be known as unbalanced transportation. All right, so these are the two types of what? These are the two types of transportation. All right, when the total amount of supply is equal to the amount of destination or demands, we say it is a balance. All right, when the total amount of supply is different from the total amount of what? Amount of demands or destination is known as what? Is known as unbalanced transportation problem. Okay, so for this transportation problem, we'll be given in a table or tableau format. Okay, in which way? In a tableau format. I want to show you this. What the tableau format, this total supply and the total cost is going to give us. Okay, I told you just to introduce to you how it works. Okay, we have here the so-called source. Okay, we have source. Okay, we have the source one. We have the source. Okay, it will be in a form of table like this way. Please, to be in a form of table. Okay, we have a source and we have destination one. Source one is going, this is going to be the source, destination one, and source two. Okay, this is going to be destination two. All right, this is going to be 1 1. Okay, destination two. Let me give like this one. See here, source one, source two, source one, destination one, source two, destination two, source three. Okay, destination three. Okay, and so on. It keeps going on. Okay, till we find the so-called, till we reach to something called destination yen. Okay, destination yen, and till here we find the so-called what? Till here we find so-called down here. It keeps going. It keeps increasing here. Okay, it keeps increasing here. Till increasing here. Till we find something called source M. Till source M. Okay, till we reach the source M here. Let's take an example. Till we reach here to the source M. Same here. Till we reach the source M. So in a source M here we have something in the box. As you see the cells, you can see the cell. This is known as a C cell 1 means the cost of transportation. The cell which you see here, the cost of transportation. Okay, this is known as the cost of transportation. Cost of transportation from source 1 to source 1 to destination 1. Cost of transportation from source 1 to destination 2, and so on. It keeps going on till we reach the cost of transportation I yen. Okay, and here we goes down here. Cost of transportation to 1 means from source 2 to destination 1. It goes down here till it reaches the cost of transportation to the M. To the M means M, the destination, M destination, and J. The column you see here, the column wise, this column wise, you can write in your words. The column wise, this is known as destination. This is a destination. Put comma or demand. Okay, or demand. What it demands? What does it demand from here to there? Okay, and the row wise, this is known as what? Supply. This is known as supply. Okay, what are you going to supply? How much? Or what does it the cost of supply for the source wise? For destination wise is a demand. Okay, we want to find the demand. Let's use the demand, will be very appropriate. This will be the demand. Okay, will be the demand. So for the demand, we'll be having a demand 1, demand 2, till demand yen. Okay, these are the total cost. These are the demand. These are the demand value here. Demand value. For the supply, we'll have supply AI, supply let's say 1, 2, till we goes down till supply AM. Okay, so here we're going to have the value of supply. Okay, we are going to have the value for supply, for this supply, for this supply, for this supply. Here we're going to have the value for the demands, demand-wise in a column-wise. Clear? So this is what you're going to use in our transportation problem. All right, in our transportation problem. Now, when the supply, let's take when total supply, for example, we have A1 plus A2 plus A3 is equal to 1,000. Clear? And here we have the demand. B1 plus B2, okay, is equal to 1,000. By this, we say that the source, we say that the transportation problem is the balance, because the supply, we say the supply, this is a supply, is equal to the what? The supply is 1,000 and demand is 1,000. So we mean to say that the problem is a balance. If the problem is a balance, then you use some method. If the problem is not balanced, then you have to add some dummy data to make it balance. Okay, to make it balance. So you have to check first if total supply, these are the total supply, are equal to the total demands. If they're equal, then you proceed. Okay, only 2 minutes. I think is a 2 minutes remaining. So let me show you one exercise so that you can understand. Okay, you can understand this transportation problem. Very simple. Let me use one method. I will mention. I think I will cover it tomorrow once again. I will touch this topic tomorrow once again. But exercise is not the same thing which I'm saying. Okay, the exercise. Let me have one exercise here just to show you how this transportation problem works. Okay. Let me take an example. All right. Here I have one exercise which is like this one. We have a problem. Sorry, this is done away. Hold on. I think this one is. Grant me only 2 minutes. See, as I told you, the transportation problem is going to be given in a form of table, in a tabular format. Okay, in a tabular format. Look at this exercise. Here we have 1, 2, 3, let's say 4. I will try to populate inside it. In this, we have the so-called, remember these are the source, okay? Here we have the source. This one are the source, this one are the source, okay? These are what? These are the source wise. These are the source, these are the source. So here is the demand. The column wise is a demand. Column wise is a demand, okay? In this source, I have the cost of transport. Let me say 11, let me say 13, let me say 17, let me say 14. Okay, let me say 14. Let it end there. Okay, 14. Look at this one. And let me say here I have 16. Here I have 18. Let me give a random number. I have 15. I have 13. Okay, here I have 13. Here I have 14, 15. Let me say 14, 17, 10, 10. Okay, 12, 11. Let me say 18. Okay, so remember, these are the cost of transport. Okay, these are the cost of transport. For every source, it has the amount, okay, to ship the whole source from source. Okay, we have here, let me give 250. This source, the second source, we have like a 300. The third source, we have like let me say like a 400. Okay, the third source we have like a 400. I don't need this one. Let me have only 3. Okay, 3. And this one I have a 200, 225. Okay, 225, 275, and 250. What to do first? First, we are going to check if, what is this? What is a 200? 200 is a demand. Okay, these are the demands. This also is a demand. This also is a demand. This also is a demand. Okay, this one, this one, this one, this one are what? These are the supply. Okay, these are the supply. So first you want to check if this transport problem is balanced by taking the total of this one. You are going to take 250 plus 300 plus 400. What is the value for this one? Value for this is equal to 950. I think is correct. 950. Okay, fine. Now I'm going to take for the demand. Value for demand, 200 plus 225 plus 275 plus 250. What is the value? I believe the value is the same. Is it same? This is going to be 500. 500 is going to be, yeah, 950. So now you came to know that this problem is a balance. Okay, this equation or this problem which you have is a balance because the demand and the supply, they are equal. So there is a method which is called northwest cost. Okay, northwest cost cell. Okay, northwest cost cell. What is that one? Northwest cost cell. There are problem which is known as northwest cost cell method. Okay, it is one. There is a method to solve when it is a balance. It's known as north. Okay, northwest. Okay, northwest corner method. Okay, we say corner method, or sometimes we say cell. You can say cell. So it is abbreviated as NYC. Okay, NYC. Okay, for NYC. For tomorrow, please don't miss it. I will cover this NYC for tomorrow just to show how it works. Okay, to show how this how this method works when you have the balance. It's very simple, very simple method. For the sake of time, let us close here, or if you can give like 2 minutes, I will show you how it works. Then you can at least go happily. Please bear 2 minutes only. Okay, 2 minutes. I'll buy you chocolate. I'll buy you chocolate. Okay, I'll buy you chocolate if you bear 2 minutes. What was the value which we gave there? What was the value? The value which we gave here was 250. Only 2 minutes. 300. 400. Okay, why am I doing this? Because we don't know what will happen if tomorrow there is no network. What will happen if tomorrow, you will be absent? At least today you can run. Is it clear? So in a northwest corner method, what does it say? It says like this one. You look in a demand. Okay, you look in a demand. Before you look in a demand, you start from the north west corner. This is a north. Okay, we look at north. The north is up here. North. This is north, right? This is a north. This is a south. So in a north, you look to the northwest. This is a west. Okay, so you start from the northwest, means to the first cell here. First cell here. You start from it. When you start from it, you look to the value. You look to the value of the demand in this destination. Okay, and you look the value of this source. Remember, these are the source. Okay, once you find this one, you look at the minimum. Okay, you look what? You look the minimum. After looking to the minimum, what do? You put the minimum here. You allocate the minimum here. I will do one cell since the time is not there. Okay, you allocate the minimum here. Here, this what value was here? Here I think I gave 10. Okay, you allocate the minimum here. The minimum is 200, right? 200. Okay. Once you do 200, and then you are going to find the difference between the destination and the source. You are going to take 200. You are going to subtract this 200 now. You are going to take 200 minus 200 is equal to 0, right? And here you are going to take 250 minus 200. The value is a 50. Okay, and then you nullify this one. This is gone. This is gone. Now you look again to the north cone. It is this one, right? It is this one. Here we have 13. Now in this, you don't consider this one. This is done. Okay, this is done. Now you look to this one. What is the minimum? Here we have a 50. We have a 225 and a 50. Here we have a 50 balance, right? Now, which is the least? Least is what? 50. Clear? So we put 50 here. 50 minus 50 is equal to 0. Now, 50 minus 225, what is the value? 225 divide 50. Divide 50. What is the value? The value is equal to, tell me first, please. I'm so weak in this one. Sam, is it correct? Is it correct, or it's 170? Is it 170? Is it 175, right? 175. Is it clear? Is it correct? 175, yeah. 175. So the value for this one is going to be 175. Now, which one to nullify? It is this one. This one, this one, this one. These cells are gone. This one. Okay, this one are gone. Now you look again to the north corner. What is the value for, which is the value in the left corner? This is the second one. The next one. Which is the least between 175 and 300 is 175. It's there. 175 minus 175 is a 0. And this one is gone. Okay. And this one, what's the value for this one? 300 minus 175 is equal to, what is the value? 125. Okay. 125. What is remaining? The remaining, it is this cell, these 4 cells here. Now you look, 275 and 125. We look to this corner here, right? Now 125 is the list. We put it here 125, here 125. And here is going to be 0. This one, what's the value for this one? The value for this one is equal to 250. Okay, this one is equal to 250. Now, which is gone? Which is gone? This is gone. This one is gone. So we have a 250 and 400. What do you do? 250. Is it 250 and 400? Is it 400? 250 and 250, I think. 250 and 400. Clear? And then we come here. This is 250 here. Okay. And we minus here. This is going to be 150. This is going to be 0. I think somewhere, maybe I have written some wrong number. Yeah, 150. This is going to be, yeah, 250 here and 150 here. So as you can see, the selected cells, 200. Now to find the optimal solution, I'm going to take 200 into 10 plus 50 into 13 plus 175 into 18 plus 25 into 15 plus 250 into 14. Clear? Then you find the final cost, the minimum cost of transporting this value. All right. So this is the brief of looking how these things works. Okay. So the selected one, you are going to multiply. 10 is what? 10 we have here. What is the value for this 10? 10 is the cost. Okay, 10 is the cost. All right, the cost for the first destination for this cell. Okay, the total cost was 250 for source. The total cost was 200 for the destination. Okay, for destination, for demand. All right, so we want to look at the minimum. So we search from the minimum, we minus the column. This one is gone because the 0 was here, and we remain with this one, and so on. So you multiply this and this, and this and this, this and this, this and that. Okay, 200 multiply 10, 50 multiply 13, 175 multiply 18, 125 multiply 11, 350 multiply 250 multiply 14. So that will be the last destination. Okay, will be the last optimum solution. So for tomorrow, we shall have the next exercise.